Hi, welcome to video 2.5b, more on implicit differentiation. So, from section 2.5, numbers 29 to 32, find the slope of the tangent line. Whenever they ask you to find the slope of the tangent line, you know it's dy over dx. It's important we understand from this point forward, it really matters with respect to what, but slope is rise over run, which is change in y over change in x. So the key thing you need to understand is you're trying to find d dx of y. So you're going to take d dx of each side. So number 30, here's the equation. Here's the point at which we're finding the slope of the tangent line. First thing I would do is that to avoid, personally I would just multiply through and then take d dx of each side, and that's determined by this right here. So this is ugly, y is ugly. Here we have a product rule. This, of course, is pretty. So this will be 8y times dy dx, then minus, and then you'll need the parentheses here because the product rule gives a sum. So first factor, derivative of second factor is 2y dy dx because y is ugly in x land, plus the second factor, which is y squared, d dx of x is 1. On the right side, d dx of x cubed is 3x squared. At this point, I distribute and get rid of all the extra parentheses, so I have minus x times 2y, or minus 2xy dy dx, minus y squared. Remember, we're trying to find dy dx at a particular number. Now, you can isolate dy dx algebraically in this expression and then eventually replace x by 2 and y by 2, which is what I did right here, or you could plug into the point right now. I isolated, so I have all the dy dx's on the left. I sent this over here because it doesn't have a dy dx, factored out the dy dx, and this is times this quantity, so I divide. At this point, you're going to replace the x's by 2 and the y's by 2, and you will end up with 2 as an answer. Okay, 33 to 40, find an equation of the tangent line this time. So instead of just the slope of the tangent line, it's the equation of the tangent line to the graph at the given point. They happen to name the graph for you, and they also give you a picture of said graph. So the point we're looking for the slope of the tangent line at is the point 81. We need a point, which they gave us. We need the slope of the tangent line, which is always dy dx. So we need to take d dx of each side. We will have 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 times dy dx because y is ugly in x land. And don't forget the derivative of 5 is 0, not 5. And then I'll send this to the other side and then divide through by 2/3 y to the negative 1/3. And then pretty that up a little bit, plug in x equals 8, y equals 1. And I get a slope of negative 1/2. And remember, it was the point 81. So there's the equation of your tangent line. This is asking you to find the second derivative of y with respect to x. So you're going to have to find, first of all, the first derivative, which is dy dx, and then take d dx of that. So here's the expression that we have. Don't miss the hidden product rule right here. So we're going to take d dx of each side. d dx of 1 is 0 minus the product, so we'll need a parentheses because the derivative of product is a sum. First factor times derivative of the second factor, which is 1 dy dx, plus second factor times derivative of the first factor. d dx of x is 1, d dx of y is 1 dy dx. Get rid of the parentheses, bring the dy dx's to the left, non-dy dx's to the right, factor out dy dx, isolate dy dx, and there is your first derivative. But they wanted the second derivative, so now we're going to take d dx of each side of the first derivative. We now have a quotient rule, so we have denominator squared, denominator times derivative of numerator, which is 1 dy dx plus 0, minus numerator, which is y plus 1, times the derivative of the denominator, which is 0 minus 1. Now what happens if I get, this plus 0 I get rid of, and this is actually just negative 1, with that negative becomes a positive. At this point, you then take that dy dx and replace it by what dy dx is equal to. And that's the tricky part. So I'm going to replace dy dx by 1 plus y over 1 minus x. The 1 minus x's will cancel. I simplify, and there's your final answer. Here's another example. This time it's y squared equals 10x. So you take d dx of each side. That'll be 2y dy dx equals 10. dy dx, therefore, is 10 over 2y, which is 5 over y. Now you're going to take d dx of each side of that. Now you'll notice before I did that, I rewrote it as 5y to the negative 1, which will just make it a lot easier. So now we take d dx of each side. That gives us a second derivative of y with respect to x on the left. This will be negative 5y to the negative 2 times dy dx, and I then replace the dy dx by 5y to the negative 1 and simplify. And there's your final answer. Okay, here it is with a negative exponent. Here it is with a positive exponent. Now, we're going to take this expression right here, number 66b, and they're specifically asking us to differentiate with respect to t. And we'll be doing that a lot in the next section, section 2.6. So we're going to take d dt of each side. Now in t land, x is ugly and y is ugly. Everybody in this party right here is ugly. So when we take the derivative with respect to t, we're going to get 2x times dx dt minus, then we have a product rule, so we'll need a parentheses because it's a sum. First factor, which is 3x. Derivative of the second factor will be 2 times y to the 1 times dy dt, plus second factor, which is y squared, times the derivative of the first factor, which is 3 dx dt, plus the derivative of y cubed, which is 3y squared dy dt, and then the derivative with respect to t of 10 is 0. So get rid of the inner parentheses, distribute the negative. You'll notice these are the two terms with dx dt. It wasn't very clear whether they wanted dx dt equals or dy dt equals. They just said differentiate with respect to t. Interestingly enough, if you look at the answer at the back of the book, all they did was bring the two terms with the dx dt's on the left, the two terms with the dy dt's on the right, and then they just factored out the dx dt and factored out the dy dt. Number 78, find the points where y to the fourth equals y squared minus x squared has a horizontal tangent line. Notice you don't have to graph this. That would be very difficult to do. They just want to know at which points does this mystery graph have a horizontal tangent line. So a horizontal tangent line, of course, means that the slope of that tangent line must be 0, and the slope of the tangent line is dy dx. So we need to find dy dx and set it equal to 0 and solve. So since we want d dx of y, we're going to take d dx of each side, so etc. Y is ugly because we're in x land, so don't forget to put these here. Isolate dy dx, you get that expression. We need that equal to 0. Now a fraction is only equal to 0 when the numerator is 0, and that numerator is 0 when x equals 0. Now, you have to check and make sure that the denominator is also not 0 at that time. But before we go any further, let's take our expression y to the fourth equals y squared minus x squared. We now know that our slope will be 0 when x is 0. So I replace the x by 0 in that expression. I then can solve that equation, and I find out it happens at y equals 0 or plus or minus 1. But you have to be careful. When y equals 0, if you go back, then this expression, remember, we found out it happens when x equals 0. If you replace both x and y by 0, you'd end up with 0 over 0, which is not 0. There would not be a horizontal tangent line at y equals 0. So the only points we get to keep are the points 0, 1 and 0, negative 1, but we can't keep this. That's a very tricky thing. And that's the end of video 2.5b.